Today we're looking at 4.4, Sum and Difference Identities. And just to show you what we're looking at here, they're right here, the addition identities. All of this part right here is where we're looking, okay? So having your formula sheet is a good idea. The other thing that's going to be valuable today is having a table of exact values. That will help us. Notice this one, it's like 1 over root 2. I prefer that to be root 2 over 2 when we rationalize the denominator. So just know that I'll be using those values. Okay, so the first identity, sum and difference identity we look at is cosine. So the cos of an angle and another angle, alpha plus beta, is equal to the cos of alpha, cos of beta, minus plus sine of alpha, sine beta. So just note that that's opposite. And you see that on your formula sheet too. So if we have the minus or the plus, we see that that's opposite, okay, for cosine. So let's try a problem here. It says express cos of 40 and 20 in terms of the trig functions 45 and 20. So all they're saying there is they're just getting us to use this. The cos of 45 plus 20 is equal to, well, we do the cos of 45 according to the formula, cos of 20, and then we do opposite the sign we see here. So we put minus the sine of 45, sine of 20 as a product. Okay, that's all they're asking us to do here. Next one, they say find the exact value of cos of 15. So what we're going to do is we're going to do this, write this as something we know. Hint I'm going to give you is this table is also found on page 153 of exact values. Sorry, page 153, 153 degrees. Okay. So 15 we need to write as a sum or as a difference related to things that we know. So in that table we know things like 45, we know 30, we know 60. Those are all things we know. So based on that, we can say that 15, you can see, is obviously 60 minus 45, or 45 minus 30. We could do either one of those, okay? So we're going to say cos of 60 minus 45. Using our identities, we know that this is equal to cos of 60 cos of 45. Now we use the opposite sign, positive, opposite to this sign right here, plus the product of the sine of 60 times the sine of 45. Okay, using exact values, we know cos of 60 is 1/2, cos of 45 is root 2 over 2, plus the sine of 60 is root 3 over 2, and the sine of 45 is root 2 over 2. Okay, multiplying this all together, I see that everything has a denominator of 4, so I get root 2 plus root 6. Okay, and that's your answer there. Looking at sine. Now this is quite the example, but we can do it. We're not even scared. Okay, so for sine, in this case, we have the same sign in between, the same. So if we add them, then we add them. Okay. So in this case, we have the sine of alpha is 5/13. The cos of beta is negative 15/17. So it says where those are. So what we need to do is we need to find the sine of alpha plus beta. Well, using identities, we know this is equal to the sine of alpha, cos of beta, same sign, cos of alpha, sine of beta. So let's look at what we know of this information. We know sine alpha, that's given to us right here. We know cos beta, that's given us to us right here. So we need to find cos alpha and sine beta. And what we're going to do is we're going to use identities to do that. So the first identity I'm going to use is that sine squared alpha plus cos squared alpha is equal to, you guys know this identity off by heart, the Pythagorean identity, that's equal to 1. Okay, and I did know sine theta. Sine theta was 5/13, so we're going to go 5/13 squared plus cos squared alpha is equal to 1. So solving for cos squared, we get 1 minus 25 over 169. So this is equal to 169 minus 25 over 169. And when we do that, we get 144 over 169. I get cos squared alpha, just carrying that down. When I square root both sides, I get cos alpha is equal to 12/13. Okay, but we have to look at this for a second. Alpha is where? It's between 90 and 180. Alpha is here. So when I have cos alpha, it really should be negative. So I have to add a negative sign there. Okay, so there's cos alpha. We're going to do the same thing with our other unknown. The other thing we don't know is sine beta. But I do know that cos squared beta plus sine squared beta is equal to 1. I do know cos beta. What was cos beta? Was negative 15/17 squared plus sine squared beta is equal to 1. So sine squared beta, I'm going to move this over. Sine squared beta is equal to 1 minus 15 squared is 225. 225 and 17 squared is 289. Okay, sine squared beta is equal to, well, 289 minus 225 over 289. Okay, sine squared beta is equal to 64 289. Square rooting both sides, I get sine of beta is equal to 8/17. Okay, here's the thing. Sine of beta. Where was beta again? Beta was between 180 and 270. So that means beta is over here. So that's beta. Keep going. So only tangent is positive in that one, so we actually have to add a negative here as well. Okay, so now we have everything we need to sub back in. Okay, because we know this and we know that. We can sub it in. So subbing in, I get is equal to 5/13 times negative 15/17. And then what was that sign in between I had? Oh, I had a plus because whenever we do sine, it's the same. And nothing I have to memorize. This is something that I just have on my formula sheet. So this is plus the product of 12/13 times negative 8/17. Okay, so on the bottom I should get 221. On the top I get 5 times 15 and 12 times 18. I'll just press pause and okay, so using my calculator I got 21 221st, which I believe to be true. Okay, next question. Say a similar identity with tangent. So just looking at your signs again. So we're going to do the tangent of 105. So we need to write 105. Somehow we're using exact values using 30, 45, 60. So I'm going to rewrite this as the tan of 60 plus 45. So that's equal to, using this identity, tan of 60 plus tan of 45 over 1 opposite sign, then right here. So minus tan of 60 times tan of 45. Okay, using our table, the tan of 60 is the square root of 3. The tangent of 45 is 1. 1 minus the tangent of 60, so it's root 3 times 1. So that's just what this is. In order to make this correct, though, I need to multiply by the conjugate. So that's 1 plus root 3, 1 plus root 3. This is just a form of 1. On the bottom, I'm going to get 1 minus 3. That's why we do conjugates. It gets rid of all radicals. And here, I'm going to get 3 plus 2 root 3 plus 1. Okay, simplifying this, I should get 4 plus 2 root 3 all divided by negative 2. One more step simplifying, I should get negative 2 minus root 3. Okay, here comes a more complicated one. If tangent of alpha equals negative 12/5, and in the fourth quadrant, and sine beta is 3/5, and we're talking about a second quadrant, find sine plus beta. Okay, so sine alpha plus beta. Sine alpha plus beta. Sine alpha plus beta is right here. It's not letting me draw. So I go sine cos plus cos sine. Sine cos sine cos plus cos sine. Okay, so what do I know of this information? I know sine beta. This is what I know. And I know tangent. Wow, I don't know a lot. Luckily, identities are going to lead the way. The first identity I'm going to use might be a little surprising. I'm going to say that tan squared alpha plus 1 equals secant squared alpha. Why? Because I know tan alpha. So the tan of an angle squared plus 1 is equal to secant. Well, guess what? Secant is the reciprocal of cos. So this might get me somewhere. Okay, so I have negative 12/15 squared plus 1 is equal to secant squared. This is 144 over 15 squared was 225 plus 225 over 225 is equal to secant squared. And I'm going to skip a couple steps. If you add those together, you square root them, and you get 13/5 is secant of alpha. So therefore, cos of alpha is equal to 5 over 13, the reciprocal. Okay, alpha is what type of angle? It's a fourth quadrant angle. So that means it looks like this. So in this one, cos is positive, and we had cos is positive, so we're going to leave that there. Okay, so now I have cos of alpha. Okay, now that I have cos of alpha, I can use that to find sine of alpha using the identity that we're used to, the Pythagorean. Sine squared alpha plus cos squared alpha is equal to 1. So so sine squared alpha is equal to 1 minus cos squared alpha. I just found cos squared alpha. We said that that was 5/13. This is equal to 169 minus 25 over 169. That is equal to 144 over 13, or sorry, over 169. Square rooting both sides, I should get 12/13. Okay, alpha again is a fourth quadrant, so in that quadrant sine should be negative. So we do have to still do some sine analysis. Okay, so now we know sine alpha, and we just need to find cos beta. And the way we can find cos beta is because we already know sine beta. Okay. So cos squared beta is equal to 1 minus sine squared beta. That's equal to 1 minus 9/25. Because we said that that was what? We said it was 3/5, so squaring that would be 9/25. When we figure this all out, we square root both sides, we get the cos of beta is equal to 4/5. Okay, where was beta again? Beta is a second quadrant angle. So it's right here. This is beta. So in that quadrant, we know that cos is negative. Okay, so now it's just a matter of subbing into that equation that we had. So the sine of alpha plus beta is equal to negative 12/13 times negative 4/5 plus 3/5 times 5/13. Simplifying this all out, we should get 48 plus 15 all over 65, which simplifies to be 63/65. A lot of work, eh? I think I'm going to skip this next one. I am. Okay, so the other thing we can use these identities for is proofs, and it's all about recognizing patterns. So here I have sine of 4 theta, cos of 3 theta equals cos and sine. Oh, look it, I have sines and coses of 2 angles. Well, this sines and coses with a negative in between. Sines and coses, so it goes sine then cos negative. Well, that looks just like this right here, sine alpha minus beta. So I recognize right away that that's the same thing, so I can use that identity. Okay, so this is equal to the sine of 4 minus 3. Just looking at that pattern, okay? And I want to show that this is the same as sine theta. Okay, well, 4 thetas minus 3 thetas means I just have theta, and that is what I wanted to show. So that one's almost too simple, hey? Okay, one more. I have cos 2 theta minus cos 4 theta, and I have to show that that is equal to 2 sine 3 theta sine theta. Okay, so I'm going to work this way. Whoops. I'm going to work this way to try and make it to be 2 sine 3 theta sine theta. Okay, what I'm going to do is I'm going to rewrite these so they are a sum or a difference. So 2 theta, 4 theta, I'm going to write them both in terms of 3 thetas and thetas. So this cos 2 theta is the same as cos of 3 theta minus theta, and cos of 4 theta is the same as cos of 3 theta plus theta. Okay, these are sums and differences and can be expressed with identities. So this first one is the same as cos 3 theta, cos theta, opposite sign, plus sine 3 theta, sine theta. Okay, and then just keep copying that minus sign. This entire thing is the same as cos 3 theta, cos theta, and now the opposite sign again, minus sine 3 theta, sine theta. Okay, combining like terms. I have cos 3 theta, minus cos 3 theta, theta. There we go. Sine 3 theta, sine theta, minus minus. So when you subtract a negative, it's just like adding. So it's like there's 2 of them. 2 sine 3 theta, sine theta. And that's exactly what we wanted to show. Okay, again, lots of questions in this section will mean you do well.